Right, we're going to have a look at isomers, a brief introduction. And here's the definition of an isomer. So it can be formed if a compound with the same formula can arrange its atoms differently. It doesn't necessarily make a lot of sense at the moment, so let's have a look at some examples. And the best examples to look at are carbon compounds. So here's a molecule with 1, 2, 3, 4 carbons. You should remember meth, eth, prop, bute. So the name of this compound is butane. And in this example, you can see that the 1, 2, 3, 4 carbons are all in a straight line. You've got to remember that when carbon bonds, it always has 4 bonds. Look at that carbon there. When hydrogen bonds, it only has 1 bond. So bearing in mind those rules, can we arrange those carbon atoms and hydrogen atoms differently while still maintaining the formula C4H10? And here is a way of arranging those carbons in a slightly different positions. Here we've got 1, 2, 3 carbons in a row here, and the carbon that was on the end here, these three are these three, the carbon that was on the end, we've taken that carbon and put it up here, and taken that hydrogen and put it over here. So it looks different. It's still called butane because it's still C4H10. We've still got 4 carbons, 10 hydrogens. But if you look in a bit more detail, you can see we've got 3 carbons in a row and 1 carbon added onto the second carbon in a row. So, in terms of names, we can call that carbon number 1, that carbon number 2, and that carbon number 3. So we're looking for the longest line of carbons, and that's 3 carbons. And you should remember 3 carbons, meth, eth, props. This is based on propane. And what we've done is we've added a single carbon to propane. So we say a single carbon is meth. Oh. Let's try that again. So we call it methyl. There's your methyl group, methyl propane. You could, if you wanted to, be specific about which carbon on the propane group the methyl is added. So you could, if you really wanted to, call it 2-methyl propane. Still got the chemical formula, C4H10, but the atoms are arranged differently, which is why butane can be called butane, or it can be called 2-methyl propane, depending on the arrangement of atoms. So these two are isomers of each other, and we've looked at names as well. Okay, so let's have a look at another example. Have a look at that, press pause and see if you can work out the name. You should recognise that that is methane, ethane, propane, butane, pentane, because, pentane, because we've got 5 carbons in it. Okay? So the question now is, can we arrange those carbons in a different way? If we follow that same methodology where we had 1, 2, 3, 4 carbons in the last example, we took the carbon off the end and put it elsewhere. Let's do the same. We've got 5 carbons now, so let's take the carbon off the end and put it elsewhere. So we'll go drawing that. So we got 1, there we go, 1, 2, 3, 4. I'm going to take that other carbon, and if we were to put it on this carbon here, it would still be 5 carbons in a straight line. So we don't want to put it on there because it would be the same as this one up here. If we put it on this carbon here, again, it would be 5 carbons in a row. So we don't want to do it there. What we can do is we can add the extra carbon here, this carbon, and we don't want to put it on this carbon or this carbon. Let's put it on this carbon here. There we go. So if I add the hydrogens in, a little bit untidily, there we go, we've got a different arrangement of the atoms. If we consider 4 carbons in a row, remember 4 carbons is meth, eth, prop, bute, so it's based on a butane structure. What have we added to butane? We've added a methyl group to butane, so again we can call it methyl butane. Methyl butane, and we've added it to carbon number, carbon number 2. There's carbon number 1, carbon number 2, carbon number 3, carbon number 4. Let's have a look at another example. Another isomer. of pentane. So again, we can have 1, 2, 3, 4 carbons in a row. Let's, instead of putting the extra carbon on carbon number 2, let's put it on carbon number 3 and see what happens. So what we want is a different arrangement, remember. So here we go, we've got the 4 carbons in a row and we've got the methyl group added to carbon number, let me just number those, 1, 2, 3, 4. But if you think about that, this molecule here, if you were to flip it round that way, it would be exactly the same as this one up here. Another way of looking at it is renumbering it, so that this is carbon number 1, carbon number 2, carbon number 3, carbon number 4. It just means we're looking at the molecule from the other side, we get the same as 2-methyl butane. So that is not it is an isomer, but it's not a new isomer. We've done it already, and we've done it here. Are there any other isomers? You should be able to pick up that we can get 3 carbons in a row, add a methyl group above and a methyl group below. So here I've added my hydrogens on and also numbered the longest carbon chain, which is 3, carbon number 1, number 2, number 3. And what I've done to my methane, ethane, propane group, let me write that down, it's based on propane. I've added here a methyl group to propane and another methyl group to propane. So I've added 2 methyl groups. Methyl, propane would be 1 methyl group on propane. Because we've added 2, we call it dimethyl propane. And we really need to indicate where we've added the methyl groups. We've got 1 methyl group added to carbon number 2. So I'm going to write that here. 2 dimethyl propane, and we've added the other methyl group also on carbon number 2, so we have to indicate both. So we call it 2, just squeezing in here, 2, 2 dash dimethyl propane. And what you find is for pentane, all of these different versions of pentane have got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 carbons. And if you add up these hydrogens, it's 12 hydrogens, 12 hydrogens, 12 hydrogens. So they're all the same formula, which is C5H12, but we've got 1, 2, 3 different isomers, 3 different arrangements for C5H12.